Welcome to Master Mathematics in Minutes. Today's topic is the substitution method. And we'll cover a couple of examples on how to solve simultaneous linear equations using the substitution method. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So what is the substitution method? Given two equations with two variables, x and y, the substitution method involves Step 1. Rearranging the first equation to display one variable, call that x, in terms of the other variable, call that y. Or you could reverse the order as well, or vice versa. And Step 2 is where we'll substitute this into the second equation. And then, Step 3 is where we'll solve for x and y. I know there's a lot to take in, but it will make a lot of sense by going through a couple of examples, which we'll now do. So in the first example, we're asked to solve the linear equations simultaneously using the substitution method. So with x plus 10y is equals to 20, and that's the first equation. And we have 3x plus 5y equals to 7, and that is the second equation. So by inspecting the equation 1 and 2, we can see that equation 1 is a lot easier to work with, because we have x without a constant in front. So if we were to bring 10y towards the right, we're able to write x in terms of y. The second equation is a lot harder to work with, because you have 3 times x and 5 times y. So to rewrite x in terms of y, you'll need to divide the equation by 3 at some point. So we'll pick the first equation to write x in terms of y. So rearranging equation 1 to display x in terms of y, we'll bring the 10y to the right hand side. And that gives us x is equal to 20 minus 10y. And we'll call that equation 3. And the second step is to substitute this into equation number 2. And so we have 3x plus 5y equals to 7 as equation 2. And we'll copy that down. 3x plus 5y is equals to 7. And that is equation number 2. And what we'll then do is to substitute this x with this x. So we will write 3, copy 3, and x is now 20 minus 10y. Move that into the brackets, and we'll copy the 5y, and we'll copy 7. And expanding the brackets is where we have 3 times 20, that gives us 60, and 3 times minus 10, that gives us minus 30y. And we'll copy 5y, and we'll copy 7. And so grouping the numbers on the left, we have 60, bringing the 7 across, that becomes minus 7. And grouping the y's on the right is where we have 30y minus 5y. And so 60 minus 7 is 53, and 30 minus 5y is 25y, and y is 53 divided by 25, which is roughly 2.12. And so we've solved for the first variable, which is y is equals to 2.12. So in theory, we're able to substitute y is equals to 2.12 into any of these equations. But we'll select equation number 3 because that is neatly written in terms of y. And we can solve for x this way. So substituting y is equals to 2.12 into equation 3. We'll replace y with 2.12. And solving for that with x is equals to minus 1.2. And there we go. We've solved for both x and y's using the substitution method. So we'll consider a second example where we're asked to solve the linear equations simultaneously using the substitution method. So the first equation is 2x plus y is equals to 50. And the second equation is 8x plus 6y is equals to 80. So again, By inspecting the equations, we can see that the first equation is a lot easier to work with, because we could write y in terms of x very easily. Equation 2 is a lot harder to work with because we have 8 times x and 6 times y. And so we'll need to divide either by 8 or 6 at some point to write y in terms of x or x in terms of y. So we'll pick the first equation to work with. So the first step is to rearrange equation 1 to display y in terms of x. So bringing 2x over, we have y is equals to 50 minus 2x. And we'll call that equation 3. And the second step is where we'll need to substitute this into equation number 2. So with equation number 2 as 8x plus 6y is equals to 80. So we'll start with that. Equation number 2, 8x plus 6y is equals to 80. And we'll copy the 8x down, we'll copy the 6 down, and we'll substitute this y with equation number 3. And that is 50 minus 2x. And we'll copy the 80 down. So with 8x copied down, 6 times 50 is 300. 6 times minus 2 gives us minus 12x. And we'll copy the 80 down. So we'll group the numbers on the left. 300, 80 bringing across becomes minus 80. And we have 12x minus 8x. So 300 minus 80 is 220. And 12x minus 8x is 4x. And rearranging that, we have x is equals to 220 divided by 4. And that gives us roughly 55. So we've solved for the first variable of x, which is 55. So in theory, we could put x equals to 55 into any of these equations to solve for y. But we'll select equation number 3 because that is neatly written in terms of x, and we can solve for y. So we'll substitute x equals to 55 into equation 3, and x is now 55, and that solves to y is equals to minus 60. And there we go. We've solved for both variables x and y using the substitution method. So to summarize, the substitution method involves given two equations with two variables x and y. Step 1 is where we'll need to rearrange the first equation. The idea is to display one of the variables, say x, in terms of the other, say y, or the other way around, or vice versa. And step 2 is where we substitute this equation into the second equation. And then we'll solve for x and y. Thank you very much for watching. This is Master Mathematics in Minutes.